science experiments, we need to first ask you a few questions to get our brains warmed up for science today. So if you have a partner to turn and talk to in your class, you can do that. And if you are alone because you're virtual, that is totally okay. You can think to yourself. So our first question, scientists, is what is science? And I'll give you a 5-second countdown when it's time to come back. So try to talk about that question. What is science? Alrighty, 5, 4, 3, 2, 1. Alrighty, welcome back, scientists. So I'm sure there are great conversations going on the other end of the screen. I wish I could hear what everyone was saying, but Kennedy and Monica, we were all talking about what we thought science was, and we said that science can be anything. There is science all around us, and we use science to discover new things. So your next question, you're just going to think to yourself for a few seconds, and then I'll give you further instructions. So we're not turning and talking for this question, just quietly thinking in our heads. So your next question, is science always perfect? Think about that for a few seconds. Alrighty. You can come on back. So if you said that science is always perfect, I want you to give a thumbs up. And if you said that science is not always perfect, I want you to give a thumbs down. Alrighty. I'm sure I'm seeing tons of thumbs down on the other end of the screen. And if your thumb is up, that is okay. But science is not always perfect. In fact, when science is not perfect, we discover new things too. Fun fact, microwaves, which is what we use to reheat our food, was discovered on accident. So if that science was perfect, we wouldn't have microwaves today, which is crazy to think about. And your last question, you're going to turn and talk to your same partner or just think on your own. Why do we do experiments? And same thing, I'll give you a 5-second countdown when it's time to come back. So why do we do experiments? Alrighty, 5, 4, 3, 2, 1. Alrighty, welcome back, scientists. So we do experiments to discover new things, and there's tons of other reasons why, but that's what Kennedy, Monica, and I were talking about. Okay, so just teachers, just a quick warning. So we will be popping balloons during this, just this experiment. So if that is going to be an issue, we'll give you a few moments just to rearrange your classroom as needed for this.
All right, so we're just going to talk a little bit more about it. So our first experiment is about balloon craziness. So I'm sure you guys have seen us holding these balloons throughout our presentation so far, and that's exactly what our first presentation is going to be about. All right, so what usually happens when you pick or put something pointy next to a balloon? Or maybe you poke a pointy object near a balloon. What do you think usually happens? I'll give you guys a few minutes to think and share with your neighbors. What happens when you put a pointy object near a balloon? All right, I wish I could hear what you guys have thought, but usually when you put a pointy object near a balloon and you poke it, it pops. But that is exactly what we're gonna learn about today in this science experiment. We're gonna prove you guys otherwise.
Whoa, 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 what are you talking about? Of course, if you put something pointy near a balloon, it'll pop.
Well,
no, it won't. You can definitely stick this pointy object through this balloon and it's not gonna pop. Who wants to say?
Me. See, I told you.
ladies, we have to use grit and optimism in this classroom in order for it to be an effective science classroom.
What is grit and what is optimism?
I'm glad you asked, Jen. So grit is about pushing forward even if you might experience a struggle. And optimism is always staying positive.
Oh, so I have grit because I want to learn how to stick the screw through the balloon, and I have optimism because I'm not getting upset that it didn't work, and I want to learn.
Exactly. All right, so now we are going to do the experiment. So what you need for this experiment is I'm going to show you, you need a balloon, you need a skewer, which a skewer is just a pointy object, and you are also going to need some oil. So what I'm going to do is I'm going to open this oil up, and I'm going to stick the skewer in, and I'm just gonna get it filled with that oil. All right, so I'm just gonna tap off some of the excess. And here we go. So I'm gonna stick this skewer straight through the balloon without it popping. All right, so here we go. Here's one side. And here's the other. As you guys can see, I have stuck that skewer right through the balloon.
That is so crazy. I want to try that, Kennedy.
All right, go ahead and try it, Monica.
I knew it wouldn't work.
And that's okay, because you know what? Science is all about trying and trying again. So even if you mess up the first time, it's really great if you try and try again.
Can I try this time?
Go ahead.
Alrighty. So when I was watching Monica and Kennedy, I had an observation. So I'm going to do the same steps that Kennedy took. And I'm just going to dip my skewer in oil. And I'm just going to get off a little bit of the excess. And I noticed that Kennedy stuck her skewer from the bottom of the balloon to the top of the balloon. And I noticed that Monica stuck her balloon right through the middle. So I'm going to try and stick it through the end, like Kennedy did. So I have one side in, and I have, oh no, it popped.
And that's okay, because science, again, is all about trying and trying again.
Should I try
Here's
again?
another balloon.
I think so.
You got it, Jen.
Monica, do you want to try with your balloon too?
I'll do it after you.
Nice job, Jen.
Thank you. Let's see if this works this time. Here, Kennedy, do you want to try helping me?
I know you can do it, Jen. That's okay. You know what? Sometimes science, we need extra tries. So let's take this balloon once more.
You know what? You two have a lot of grit because it didn't work the first time, but then you kept trying.
That is so true. So we're gonna keep looking. We're gonna go through one side. And it went through the second time. So sometimes you just have to keep trying and you'll get an end result that looks pretty darn cool.
Alrighty, so I have tons of grit because you know what? I messed up 2 times, but that's okay because science is not always perfect. But there is a reason why this experiment works. So, latex, which is what balloons are made out of, is a really stretchy material. So if you take a balloon and you stretch it, it's extra stretchy like this. So the sticky part to the latex sticks right onto the skewer, which is why we can get the skewer through the balloon. Now I want you all to look at this balloon I have right here. So this balloon is covered in dots. So watch what happens when I blow up the balloon. So it might be a little bit difficult for you to see, but what happened to the dots?
Here, I'll stop sharing just one moment.
What happened to the dots? You can see that some of them are really big and faded and stretched out, and some of them are not faded at all, like the ones over here and on the bottom of the balloon. So what this means is the dots that are in the middle are extra stretched out because it's the least strong material that the balloon is made out of. And on the top, the balloon is extra strong because there's more latex and more material there. That's why our dots on top of the balloon, I know it's a little bit difficult for you to see, but I promise you that they're there, are extra small and extra dark. And these dots are really big and really faded. So that's showing how, again, in the middle, the balloon is really weak. And on the 2 ends where Kennedy was able to stick it in, both times are really strong. So that's how that works. Awesome. Alrighty, so I want you all to take a moment and I want you to think about eggs. We're moving on to our next experiment. So just a dozen eggs that you would buy at the grocery store. Maybe you use these eggs to cook. Maybe you use these eggs to bake, like I did this morning when I made myself eggs. But have you ever played with eggs? Here, watch this. Catch the egg, Monica.
Whoa, you're gonna make a huge mess.
Oh no, but ladies, guess what? We can actually play with eggs in a scientific way. Maybe just not so much as Jen and Monica just did. They just dropped an egg on the floor, but that's okay. Science can be messy. So the first thing that we're gonna ask is what happens when we put a raw egg into vinegar. So let me get a cup and let me get some vinegar. And we're gonna see what happens when I put, let me just put the screen, sorry. If I put vinegar into a cup with an egg. All right, so the egg is in vinegar, as you guys can see. Let me stop sharing my screen really quick. I filled it with vinegar. And so unfortunately, this process takes up to 3 days to actually work. So 3 days ago, we did this experiment and we wanted to show you the results of what we got. So Monica's gonna show you what happens when an egg is put into vinegar.
So as you can see here, the egg is super squishy. And this isn't a hard-boiled egg. This isn't a cooked egg. It's still a raw egg, but it's very, very squishy. And it's almost a little bit see-through as well.
Alrighty.
Isn't that cool, Jen?
That's so cool.
That's cool. But I think that this one right here is cooler.
Yeah,
So
why is it colorful?
I put this egg in food dye and I let it sit in this food dye for 2 days. So look at it. It's like a tie-dye egg and it's squishy as well.
Awesome. All right, so what we are gonna do now is we are going to do an experiment with this. Oh no, Jen, what did I do? Thank you. Oh wait, I don't know if they can see that. Sorry, we're experiencing some technical difficulties right now.
But we're having grit and we're fighting through this technical difficulty issue.
All right, if you guys can't see my screen, please let us know. So we're gonna do an experiment with eggs that are raw and eggs that have been in vinegar. So we're gonna take a plate, and what we're gonna do is we're gonna bounce both of the eggs, and we're gonna see what happens. So we're gonna bounce an egg that's raw and has not been touched in vinegar, and we're gonna take an egg that has been in vinegar, and we are going to bounce it. All right, so I'm gonna stop sharing, and we're gonna see what happens. So this is me bouncing the raw egg. So let's see what happens. 3, 2, 1.
Try again. 3, 2, 1.
Oh, it cracks.
All right, so as you guys can see, it did not bounce. And instead, I don't know if you guys can see that, but the egg has been cracked.
That's really cool, but I want to try this one that's been sitting in vinegar for a while. I wonder what will happen here. Did you see that?
Oh my gosh.
It bounced, just like a bouncy ball.
Awesome.
That is so cool. So now we know that eggs that have been in vinegar can bounce. So let's figure out some science behind this. So when we put the egg into vinegar, the vinegar is going to dissolve that hard shell. So a raw egg, it's really hard. You can tap on it, whatever you need to do, and it's very a hard shell. And when we put it into vinegar, that vinegar is going to make the hard shell go away, and it's just going to take the inside stuff of the egg, and it's going to make it really squishy, which allows it to bounce.
Alrighty. I think we need to take this experiment up one level. I don't know if you guys believe us that rubber egg is still raw inside, because why wouldn't it crack if it was dropped just like the raw egg? But we are going to prove to you that this egg is indeed raw. Who wants to see this cool experiment?
I do.
I'm going to stick a skewer through the balloon, and through the egg, and look, this is what is left of the membrane that Kennedy was just talking about. It's just a really rubbery shell. And look, who wants to make some scrambled eggs?
Not me.
Alrighty, friends.
All right. Let's go back to screen sharing.
Hey guys, when are we gonna make toothpaste so that I can brush my teeth? I ran out of toothpaste.
No, Jen, we're not making that kind of toothpaste.
All right, we're making toothpaste for elephants. That's awesome because my friend Ellie the elephant over here hasn't brushed her teeth in months. I need some help.
That's right.
All righty, Monica, show us how you do it.
So we need 4 simple ingredients for this experiment. The first one is water, just normal water, and then we're going to add some yeast to that water. Yeast is one of the ingredients that you add when you make bread because it makes the bread rise up nice and tall. Then after that, we're gonna get a water bottle and we're gonna add some hydrogen peroxide to that water bottle. Now, hydrogen peroxide is a really cool chemical because it's made of hydrogen and peroxide, and sometimes you put it on cuts to clean out all the dirt. So I'm just gonna add some of that to the water bottle. And then I'm gonna add some dish soap to that. All right. So what do you think will happen when we mix the yeast and the water mixture into the hydrogen peroxide and the dish soap mixture? Well,
Let's see what happens. All right, before you do
Here,
that,
let's do it right over the plate too.
we'll have a full view of what's
All right,
going to
ready?
happen. Oh my
Look,
goodness.
it's rising up out of the bottle. Wasn't that cool, Jen?
It's slowly but surely rising. Let's see if it'll make it out.
There it goes.
There it goes.
I think that was pretty cool, but I think I've seen cooler. Here,
Really?
watch this. Help me clean off the table, scientists. I think we have one more experiment that we need to do for our friends today. Okay, so you see I'm getting on gloves, and I'll explain that in one moment. Okay, so we are going to be needing test tubes for this experiment today. And I'm going to line up all my test tubes, and I'm going to get all this extra stuff off the table just because we might make a really, really big mess. Okay. So what I'm going to do is I'm going to use something called 12% hydrogen peroxide. So Monica used something called 3% hydrogen peroxide, but we are going to use something that's extra strong. So I'm going to show you the steps. So first, I am going to put a lot of hydrogen peroxide into each test tube, and Kennedy is going to add the dish soap for me. And she's going to add a big, big squirt. Do we need a little bit? Yeah, tons of dish soap. Okay. So I'll add a little bit more here just so we can have an extra crazy reaction. So the next step is going to be to add food coloring. So I'm going to add a ton of purple food coloring to this one. Kennedy's going to add orange, and I'm going to add yellow and pink to the next two. And then we're going to get some fresh skewers for each one, and we are going to stir it up just so that we can have really pretty colors form.
So Jen, what do you think is going to happen?
I don't know, to be honest with you, but I do know that this is extra strong hydrogen peroxide. So do you think maybe it might be a little bit crazier than Monica's experiment?
Maybe.
Okay. So the next thing that I need, friends, is yeast. And I have a ton of warm water right here. And I am simply going to add in some yeast packets. I have one yeast packet, and we're cleaning up this whole table right now for you, friends, because this is going to go crazy, I think. And I'm going to add in 3 packets of yeast. I know that sounds crazy, friends. But I have 3 packets. Yep, and Kennedy's going to help me mix. And we're going to move everything off the table right now, too, for you, because it is really going to go crazy. We're going to move everything off of this side.
And this is what the yeast mixture looks like. All right.
Alrighty. So, friends, do you think that we are ready to put this yeast mixture into all of these test tubes?
Can we have a countdown?
I don't know if I can hear you. We're going to do more dish soap just to make it even crazier. Alrighty. Oh no, we forgot food coloring in this one. Quick, give me any color. More orange. Awesome. Okay. I think we need a countdown and everything off the table. Who's ready?
5, 4.
Wait, 1 second. Sorry, friends. My test tubes got a little out of order. Okay, we're gonna move all this stuff too, just because we have some items that we don't want to get ruined.
5, 4, 3, 2, 1. Oh my goodness.
Oh.
That is crazy.
My goodness. Do we see how much this is exploding? There's
Oh my goodness.
steam coming off the top. Look at that. How cool is that? I will let you guys just watch this for a few moments because it's still going. Who thinks we should add a little bit more yeast?
Me.
Oh boy.
And we'll get a closer look at it.
Alrighty. And that is our elephant toothpaste activity.
So the reason this experiment works so well is that the yeast causes a super fast reaction. Pouring that yeast mixture into the cup causes all the foam to rise up out of the beaker.
All right. So that is all we have for you guys today for science experiments. We hope you had fun. So if we have any questions in the chat right now, you guys can feel free to ask some if you have any questions. We'll give you a few minutes if you want to type anything. All right, and the first one is, can an elephant toothpaste experiment be done on a larger scale?
It can be done on a larger scale. So the first one that you saw, Monica used something called 3% hydrogen peroxide, and that's just how strong it is. So that's just basically saying it's 3% strong. I used something called 12% hydrogen peroxide. So that means it was 12% strong. And they actually have something called 30% hydrogen peroxide. I was not able to find that though. So we stuck with the 12%, but when I saw videos, I saw the 30% shooting up to like the sky. It's crazy. So it can be done on a larger scale.
The second one is, can you post the experiment for us to replicate in the school or at home? Definitely. We will definitely reach out. We can share anything. You can email. Perfect. And then the second question is, if you put vinegar on the skewer, would the balloon pop?
Ooh.
Should we try?
We can try because we have an extra balloon.
All right.
So our question is vinegar. I don't know. You know what? I'm going to have Britt and I'm going to be the one to test this out. But let's see.
I see a lot of these students must have a lot of curiosity because they're asking questions about these experiments, which is super cool.
Right.
Definitely.
So I think it's pretty soaked in vinegar.
Yeah.
All right, let's see if it works. I don't know if it's going to work. You might want to hold your ears. Whoa.
Oh.
So it went through one end. Let's see if I can get it through the other end. That's where I struggled last time.
Go for it, Jen.
Unfortunately, I don't think that this is going to go through. Let's say. Oh my gosh, it did go through. I am so sorry for not having grit with that one, but it did go through. That is awesome. I never even would have thought that vinegar would work. That's great.
Yeah, so definitely different liquids like the vinegar now works. We know that. Oil works. So definitely, that was a great question. Another one is, how did the color go away when it changed to foam pertaining to the elephant toothpaste?
So I think the color went away because there was a lot of other materials in it. So the hydrogen peroxide and the dish soap is what is causing the bubbles to form. So since there's so many bubbles that are constantly forming because it's a chemical reaction, I think that there's not enough food dye to let it go throughout the whole thing. Maybe if I used more food dye, it would work. We can try again with more food dye and see if it works.
Possibly. Yeah.
Okay.
All right. So that would definitely be an experiment we can do at home too, if you want to guys want to try it out too. All right. Do we have any more questions? Did the elephant toothpaste stop growing? Let's go ahead and take a look. Do you guys think it stopped growing?
Should we try putting more yeast on it and see
Yeah,
if
let's see.
Yeah.
starts to go? Oh, wow. It's still going now.
Awesome. So you guys can see that the yeast is truly what makes the reaction happen. So when she put the yeast back onto it, it grew even more. So after a while, it does run out and it stops, as you guys just saw. But when you put the yeast back on it, it'll explode again. All right, let me see if we have any more questions. Will the balloon experiment work with the water balloon?
Oh. Huh. I am not sure, but we can definitely try that, and then we can reach out to Shine On to give them that answer, and then they can reach out to you for that answer. But you can try that at your house.
Yeah, definitely. I'm not sure entirely if it would work, but if you want to use vinegar or try oil, I'm sure it would work. All right, any other questions? All right. Well, thank you guys. Let me pull up our screen one last time. Thank you guys so much for being with us today. We had a blast doing all these crazy fun experiments for you, and we're so grateful that you guys joined us today.
Have a great rest of your time with all the
Bye.
presentations. Bye.
Sorry, I was muted there for a second.
Good.
Thank you guys all. Thank you. That was amazing. And thank you guys for all coming to this amazing workshop and conference. I hope that you love learning about science and seeing the astronauts in space. Today wouldn't be so special without all of you being here and learning. So thank you guys so much.
Yeah.
Thank you.
Bye.
Bye.
Bye guys. Thank you.